What's up, guys? Thank you for coming back to this channel. Today we're going to be doing C++, Introduction to Variables, and we're going to have fun with C++ for a change. Now, in C++, Introduction to Variables, there is data. In lesson 1, which was statements and the structure of a program, we learned that the majority of instructions in a program are statements, and that statements are grouped into functions. These statements perform actions that hopefully generate whatever result the program was designed to produce. But how do programs actually produce results? They do so by manipulating, reading, changing, and writing data. In computing, data is any information that can be moved, processed, or stored by a computer. Programs are collections of instructions that manipulate data to produce a desired result. Now, I hope all of us are understanding this. A program can require data to work in many ways, from a file or database, over a network, from the user providing input on a keyboard, or from the programmer putting data directly into the source of the program itself. In the Hello World program, from the aforementioned lesson, or the lesson previously, the text Hello World was inserted directly into the source code, providing data for the program to use. The program then manipulates this data, sending it to the monitor to be displayed. Now, objects and variables. All computers have memory called RAM. This is short for random access memory, that is available to your programs to use. You can think of RAM as a series of mailboxes that can be used to hold data while the program is running. A single piece of data stored in memory somewhere is called a value. In some order, programming languages like Apple Basic, you could directly access these mailboxes. A statement could say something like, go get the value stored in mailbox number 75, or whatever number it is. In C++, direct memory access is not allowed. Instead, we access memory indirectly through an object. An object is a region of storage that has a value and other associated properties. When an object is defined, the compiler automatically determines where the object will be placed in memory. As a result, rather than say go get the value stored in mailbox number, whichever number, number X, let's just keep it number X, we can say go get the value stored in this object, and the compiler knows where in the memory to look for that value. This means we can focus on using objects to store and retrieve values, and not have to worry about where in memory they are actually being placed. Objects can be named or unnamed anonymous. A named object is called a variable. The name of the object is called an identifier. In our programs, most of the objects we create will be variables. In general programming, the term object refers to a variable, data structure in memory, or function. In C++, the term object has a narrower definition that excludes functions. Variable instantiation. Sorry guys, I'm reading my notes and I discovered I don't have a good handwriting. In order to create a variable, we use a special kind of declaration statement called a definition. We clarify the difference between a declaration and a definition later. Here is an example of defining a variable named x. Now at compile line, hold up. At compile time, when the compiler sees this statement, it makes a note to itself that we're defining a variable, giving it the name x. And that it is of type int, which is an integer. More on types in a moment. Like I will expound on more types in a moment. From that point forward, whenever the compiler sees the identifier x, it will know that we're referencing this variable. When the program is run, the variable is instantiated. Instantiation is a fancy word that means will be created and assigned to a memory address. Variables must be created before they can be used to store values. For the sake of, let's just say for example that variable x is created at memory location 140. Whenever the program then uses variable x, it will access the value memory in location 140. A created object is sometimes also called an instance. Now data types. So far we have covered that variables are a named region of storage that can store a data value. A data type is more commonly just called a type. It tells the compiler what type of value the variable will store. In C++, the type of a variable must be known at compile time, when the program is compiled, and that type cannot be changed without recompiling the program. This means an integer variable can only hold integer values. If you want to store some other kind of value, you need to use a different variable. Integers are just one of the many types that C++ supports out of the box. For illustrative purposes, here is another example defining a variable using a data type double. C++ also allows you to create your own user-defined types. This is something we'll do a lot in future, and is part of what makes C++ powerful. Defining multiple variables it is possible to define a number of variables of the same type in a single statement by separating the names with a comma. Now the following two snippets of code are effectively the same. Those two are the same. When defining a multiple variable this way, there are two common mistakes that new programmers tend to make. They're neither serious, since the compiler will catch this and ask you to fix them. The first mistake is giving each variable a type when defining the variables in sequence. Like, let's try this. Now, the best way to put this is this here. That is the correct way. The second way here is the wrong way, which will give us a compiler error. Now, the second mistake is to try and define variables of different types in the same statement, which is not allowed. Variables of different types must be defined in separate statements, like int. Now you can see that this is a wrong compiler error. This is correct, but it's not recommended. Now this one can be changed to this, which is correct and recommended because it's easier to read. Now the best practice, although the language allows you to do this, avoid defining multiple variables in a single statement, even if they are the same type. Instead, define each variable in a separate statement, and then use a single line comment to document what it is used for. In summary, today we learned that in C++ we use variables to access memory. Variables have an identifier, a type and a value, and some other attributes that aren't relevant here. A variable's type is used to determine how the value in memory should be interpreted. Now in the next lesson we will look at how to give values to our variables and how to actually use them. Thank you, and have a nice time, day or night. Like and subscribe. If you have any questions, I will leave my number in the description below. You can call me and I will answer.